Hey, good morning, everybody. All right, so today we're going to talk a little bit more about quadratics. There's a couple things we want to cover. We're going to talk about average rate of change, and we want to talk about vertex form and lines of symmetry. So those are kind of the three things that we're going to cover. Let's start with average rate of change. So average rate of change obviously is just slope, right? So when we talk about average rate of change, usually they're going to give us some interval that we want to find the rate of change over. So for example, let's say they told us that f of x equals x squared plus 6. All right, so we have some quadratic function, but obviously it doesn't have a slope, right, because it's not a straight line. So it's going to say something like, find the average rate of change, and then they're going to give you some kind of interval. Like, for example, they might say between 2 and 4. So find the average rate of change when x is greater than or equal to 2 and less than or equal to 4. So here's how you're going to do average rate of change. You're going to take these two numbers that they gave you, and you're going to plug it in and actually find out what those points are. So you can make a little table, right? So if I plug in 2 squared is 4, 4 plus 6 is 10. When I plug in 4 squared is 16. 16 plus 6 is 22. So I plug in the 2 points, the end points of what they want me to find my average rate of change on. I find out what those 2 points are, and then you're just going to find the slope between those 2 points. So it's just like back to linear equations. They just want to know what's the slope between those two things. So I'm going to go y2 minus y1 over x2 minus x1. And that, in this case, is going to give me 12 over 2, or 6. So the average rate of change for this function between 2 and 4 is going to be 6, or 6 over 1 if you want to think of it that way. So average rate of change is very much just find the slope. You just have to find the points that they want you to find the slope between first. So use what they give you, plug it in your function, kick back out whatever you need. That's average rate of change. Let's talk about vertex formula. Or vertex form, sorry. Vertex form is the easiest way that we can write quadratics if we want to graph them. So standard form works really, really well if we want to factor them. That's what we worked with last chapter, right? When we were factoring. Vertex form looks something like this. F of x equals a, x minus h squared plus k. Right? And this h and this k here, those are our shifts. So the h here is our horizontal shift. And our k is our vertical shift. And those numbers, so if you think about what our regular parabola looks like, right? Let's say I had something like this. All right, so here's my parabola. These numbers are basically just going to change where my vertex here is located at. So if my whole function gets shifted to the right 4, my vertex will also get shifted to the right 4. And if my whole function gets shifted up 2, my vertex also gets shifted up 2. So vertex form is going to tell us basically with the shifts where the vertex is. That's why it's actually very helpful. So let's take a look at what that might look like with some numbers in there. So let's say you had f of x equals 3 x plus 2 squared minus 6. And they say, where is the vertex, right? What's my vertex? So the shifts are going to tell you where your vertex is. We always start at 0, 0 because our parent function has a vertex at 0, 0. So start at 0, 0, and then just move whatever your shifts say. So inside here we have our horizontal shift. If it's plus 2, that means we're going left 2. So we want to go left 2. On the outside here, minus 6 means we're going down 6. So if I'm at 0, 0 and I go left 2, that would be negative 2. If I go down 6, that would be the point negative 2, negative 6. So my vertex of this function is at the point negative 2, negative 6, because that's where my shifts told me to move it to. So I start at 0, 0, and I just move exactly what it says. Left 2, down 6. Let's try another one of those. So if I told you that g of x equals 2/3 x minus 7 squared plus 4. I look at my shifts. On the inside here is my horizontal shift, so minus 7 means it's going to go to the right 7. This up 4 is going to go up 4, plus 4, right? That's my vertical shift. So if I start at 0, 0, and then I go right 7, up 4, my vertex is going to go to 7, 4. It just is going to shift it to the right 7, positive 7, up 4. Now my vertex is there. And if you think about what's really nice about this, now that you kind of have an idea of where that vertex is, think about when you made your tables on Monday and they didn't turn out like great, because you're like, where in the world is that point where they start repeating itself? Now you know where to start from, because you know where the vertex is. So we obviously want to include the vertex in our table so we can see what's going on the right side, what's going on the left side. So maybe I start my table at 5, and I go 5, 6, 7, 8, 9, instead of negative 2, negative 1, 0, 1, 2. And that'll kind of tell me where my vertex is, because I know I shifted it right 7 and up 4. So let's talk about line of symmetry, and then we'll be done. So every one of these parabolas has a vertical line of symmetry where this will reflect over into this side, right? All the tables, for example, let's say we had like y equals x squared, right? If I plug in negative 2, I get 4. If I plug in negative 1, I get 1. If I plug in 0, I get 0. If I plug in 1, I get 1. If I plug in 2, I get 4. So because these keep repeating like that out, that's my line of symmetry. So sometimes it will ask you, where is the line of symmetry for this parabola? Well, the key to that answer is the vertex, right? So my vertex is going to tell me exactly where my line of symmetry would be, right? Because if it is at 7, for this one, it's going to be the line x equals 7. So if it's shifted to the right 7, right? Think of this whole thing, shifted 7 to the right. I would want this horizontal line to be at 7. It's always the x-axis, or the x value, that's kind of what we're looking at, right? Because it's going to be a vertical line of symmetry. If it was horizontal, we know that horizontal lines are y equals, vertical lines are x equals. So this is going to be like x equals 7. A really good thing if you're not sure what the line of symmetry is, is this little thing that says, like let's say you got, did they give you any of those in your homework? Let me check real quick. No, I think we're good. So if you just look for this vertex, the x value is going to be your line of symmetry. So let's say I give you one more. Let's say h of x is x plus 1 squared plus 10. So my horizontal shift is in here. Plus 1, remember that's opposite, so it's going to go left 1, up 10. So my vertex, I'm just going to kind of follow the same method. I go start at 0, 0, I go left 1, up 10. That would be the point -1, 10. So that means my line of symmetry is going to take the x value, x equals -1. That's pretty much it. That's all you need to know about vertex form. It's really nice to know where that vertex is. That's very important for us, especially anytime we're graphing. We have to include that vertex. It's the crux of the whole graph, right? It's that whole part where it's going from increasing to decreasing or decreasing to increasing. And it's really important for us. So vertex form, average rate of change, vertical line symmetry, got it all.